All right, algebra. Let's get to work with lesson 10.4, the Pythagorean theorem. You're on page 549 in your book. Let's get started. So, the Pythagorean theorem. In a right triangle, the side opposite the right angle is the hypotenuse. So, if I'm drawing a right triangle, the side opposite the right angle is the hypotenuse. So that right there is the hypotenuse. Let's see if I spelled that right. Looks pretty close. All right, so that's your hypotenuse. Now, the other two sides are called legs. You got a leg there and a leg there. Now, to find the length of any side of a right triangle, when the lengths of the other two are known, you can use a formula named for the Greek mathematician Pythagoras. And that formula is simply a squared plus b squared equals c squared, where the two legs are a and b, and the hypotenuse is c. Okay? So this leg squared times this leg squared, or plus this leg squared, equals this squared, the hypotenuse squared. So let's take a look at example 1. It says find the length of the hypotenuse of a right triangle if A is 8 and B is 15. Okay, so let's draw that triangle. This looks pretty good. That's 8 and that's 15. And we want to find out what this is, what this distance is here. Okay, so if, let's make this A and this B, it doesn't matter, A squared, so we got 8 squared plus B squared, which is 15 squared, equals C squared. All right, so we know A squared is 64, plus 15 squared is 225, and if we add those together, that will give us C squared. Well, 64 plus 225 would be a total of 289, and that equals C squared. So to figure out what C is, take the square root of that side, square root of that side, that gives me C. And this, the square root of 289, is the positive or negative 17. Because 17 times 17 is 289, or negative 17 times negative 17 is 289. Now, could a length be negative? No, so we know that it's only the positive root. So C is 17. Okay? All right, let's do another one. Let's take a look at example 2. So I've turned to page 550. Find the length of the missing side. If necessary, round to the nearest hundredth. Okay, so we have a shape that is similar to this, where we don't know A, but we know C, and we know B. Okay, so remember, A squared plus B squared equals C squared. Okay, in this case, we don't know what A squared is, but we know B squared would be 100, and we know C squared, 25 times 25 is 625. Okay, so to figure out A squared, subtract 100, subtract 100, and we have A squared equals 525. To get A, you take the square root of A squared, do the same thing over here. So A equals the square root of 525, and if we punch that into our calculator, we get approximately 22.91, and our label in this case doesn't look like we have a label. So 22.91 would be our length for A. Now, the last piece of the puzzle that we want to take a look at is a group of 3 whole numbers that satisfy the Pythagorean theorem is called a Pythagorean triple. Examples include things like 3, 4, and 5, because 3 squared plus 4 squared equals 5 squared, right? 9 plus 16 equals 25. Okay, so that's a Pythagorean triple, where these are all whole numbers. They're not decimal numbers like we saw over here. All right, so let's look at the standardized test. What is the area of triangle ABC? Okay, so we have this triangle here. It's a 20 by 12, and we don't know what that side is. Okay, so, but I know that a squared plus b squared equals c squared. Okay, and in this case, I'm going to have x squared plus 144 equals 400. Okay, because that's the hypotenuse opposite of the right angle. All right, so minus 144 and minus 144. That leaves me with x squared equals, borrow from there, make it a 3, that becomes 9, 10 minus 4 is 6, 5, 256. So now I want what number times itself gives me 256. Okay, well, I know it's more than 15 times 15. Let's try 16 times 16. 6 times 6, 36. 6, 7, 8, 9. Start with a 0. 6, 1. 6, 15. Carry the 1, 2. So 256. So we know that x equals 16 because we take the square root of that and the square root of that. All right, so now if x is 16 and the other side is 12, to find the area, now I can take length times width, or base times height, divided by 2. So 16 times 12 divided by 2 would be the same as 16 times 6. 16 times 6. 6 times 6, 36. 6, 7, 8, 9. 96 units squared, which lines up with letter A. Okay. So that is the Pythagorean theorem. Now the last part, if you look at example 4, you can use the Pythagorean theorem to check for right angles. So for example, let's look at A. It says 20, 21, and 29 are the three sides. You know 29 is the hypotenuse because the hypotenuse is always the longest side. Okay, now you can plug those numbers in, and as you can see here, if you wind up with 841 equals 841, well then it is indeed a right triangle. However, if it gives you the sides, 12, 8, and 10, and you plug that into the formula, 12, 8, and 10, and it comes out to 144 equals 164, that is not true. So in that case, that would not be a right triangle. Okay, so go ahead and get started on your work. Any questions that you have, feel free to give me a shout out at email, text, phone call, or log on between 9 and 10 o'clock, and I would be happy to answer your questions. Have fun.